defenses or controls that we need to master to write secure software. A lot of this material comes from the OWASP Foundation, so that people and organizations around the world can make informed decisions about web and API and mobile and all forms of application security risk. We're going to look at one of our documentation projects at the OWASP Foundation, which is the OWASP Proactive Controls. This project is a list of the top 10 defensive practices that you need to master to write secure software. And my name again is Jim Manico. I'm a volunteer for the OWASP Foundation. I used to be a board member for OWASP. And I'm primarily a Java programmer who focuses on security engineering. Our first control of our top 10 list is to define security requirements. The question that I ask most companies is, what does security mean to you? What does security mean to you? Or what do you define a piece of secure software to be? And very often the answers that I get are philosophical. And as a developer, I like philosophy, but it doesn't help me write secure software. I'm an engineer. I need requirements. And so I believe all secure software starts with the clear definition of what security means from a requirement point of view. For example, you look at the Microsoft SDL. This is one of the most popular software development life cycles that we see in the world today. And very early on, they're suggesting the second thing you should do is to establish clear security requirements. And pretty much any SDLC, any software development lifecycle that we look at is going to ask about requirement definition. So one of the projects at the OWASP Foundation, this is one of the closest things that we have to a standard, is called the ASVS standard, the Application Security Verification Standard. We're currently at version 3.0.1. Version 4 will be released at the end of this year. This is a set of requirements that was built for and built by developers who do security engineering. It defines 3 levels of risk that describes individual controls that you need to master to write secure software. It's very similar to other standards like ISO 27034, which is another secure software standard, but it goes into a lot more detail. You'll see 3 levels, and this is something that I recommend you in Nepal who are trying to build or manage secure software. This is a standard that you should be looking at to help us understand, not from a philosophy point of view, but from an engineering point of view, how do we build a secure web application? How do we build a secure API? There's 3 tiers of requirements. Level 1 is easily scannable in terms of verifying for security. Level 2 is a bit more challenging to test. They're much more challenging controls. And level 3 is going to be our most difficult controls that we reserve for military or banking or infrastructure. When you look at this standard, you'll see this right here. It's a list of individual engineering requirements broken down into 3 tiers of severity. And this is a way for you, those of you who are doing software development or who are responsible for software, who work for the government or banks or telecom. Banks, government, telecom, you've got to master secure software as part of your security discipline for those organizations. This standard, the Application Security Verification Standard, it's free, it's an open source document. This should help you get started in defining what security is for your software. All right, the second of our top 10. We're talking about the OWASP Proactive Controls. It's a top 10 list of defenses that you want to master to build and maintain secure software. This presentation I'll release through the conference, so you'll get a copy of this at the end. So level 2, leverage security frameworks and libraries. When you're a developer trying to build secure software, you shouldn't have to start from scratch. We can leverage a lot of different built-in security in the frameworks that drive the world today. I like Apache Shiro here. They do great access control that's very detailed. We have the Django framework from the Python world, which really was built from the ground up with security in mind. We have Spring Security, also for the Java world. Spring Security has a lot of default built-in security, just like Spring Boot does as well. So the goal here is we don't want to have to start from scratch. We want to leverage open source that's already doing security well. And there are many examples of this in the world. And so, but why do we care about, what makes these third-party libraries a challenge in the world today is that they themselves are filled with bugs as well. All software has security bugs. So here's a list of security bugs that we've seen in common open source software that can do damage to your organization. So we're looking at a lot of remote code execution in open source software. It doesn't get any more damaging than this. How about this one? This is CVE. This is a common vulnerability enumeration from 2017, 5638. Does anybody know why the whole world cares about this individual bug? Equifax. This is one of the greatest breaches of sensitive data in the history of the US, and it affected many other countries around the world. This is like everyone's driver's license, credit history, finance history, extremely detailed. And the reason that data was lost is because one server in Equifax was not patched. And we knew about this. This is a public issue that a large number of people patched. Even at Equifax, they patched most of their servers except for one. And that led to the greatest breach. So if you're going to use security frameworks, that's great. You've got to keep your software up to date. In the world of infrastructure security, updating your operating system, I think it's not that difficult these days. It's become easier over time. When you get a security patch, you can usually update your operating system with a good assurance that you're not going to destroy your organization. When we look at developers building software, that's not the case. If we just start updating libraries that we care about when building software, we're going to break software. So this becomes a very challenging issue. So what I recommend is, every application has these issues. Every application uses third-party software. One of the projects from the OWASP Foundation, it's one of our flagship open source projects, it's called the OWASP Dependency Check Project. This is a utility that you can run against your software code base, and it will alert you if you're using any third-party libraries that have known security vulnerabilities registered in them. We also have a program called retire.js from one of my friends in Norway that looks at your JavaScript code and will let you know if there's any security vulnerabilities in the JavaScript libraries you're using. So this is important. When we're using third-party libraries and frameworks and other utilities to help us build software, we have got to, on a daily basis, check our code base to make sure the utilities that we're using and the frameworks we're using are up to date and don't have any known vulnerabilities in them. This is a very challenging part of secure software development. Number 3, we're talking about the OWASP proactive controls, defenses that all software developers need to master to write and maintain secure software. Let's talk about secure database access. Those of us who've done security for a long time, we know about SQL injection. Who in the room has heard about SQL injection before? Who's heard about SQL injection? Some of you. Who took class with me yesterday? Okay, you, stand up. Get up. How do you stop SQL injection?
By using stored procedures,
Parameterized queries. Give him applause. That's good. So this is the only, you may sit down now, thank you, sir. The only way that you can build secure database queries in software, not through validation, not by using a garbage web application firewall, you need to build parameterized queries. Because, look at this email address. Hey Jay, is this a real email address?
Sure.
Yes, it is. Does anybody not agree? Is this a real email address?
Why not?
And not only is it a real email address, It's live. This is one of my email addresses. So if you don't believe me that this is a real email address, go ahead and send me some email and I'll respond to you. What will my response be? Believe. It's real. The problem with this valid email address is that it's painfully dangerous to put into a SQL statement. This is RFC compliant. It will validate as a legitimate email address. It's active right now. Do you believe? Hey, Vikas, do you believe me, Vikas? If you don't, go ahead, try it. Go ahead, try Vikas. We'll see. But it's unsafe for SQL. Here's a basic select statement where I'm selecting data from a customer table where someone entered in this new and valid email address. There's my valid email address. And here's the final query. Select data from the customer table. Look at the bottom one, actually, right there. Select ID, social security number, credit card number, mother's maiden name from the customers table where email is Jim or 1 does not equal manico.com. The last bit there, 1 does not equal manico.com, right in there, that's called a universal truth attack. It's always true, which means everything from the customer's table will be returned. This is what SQL injection is. Yes, Jay?
Are you familiar with Bobby Tables?
Bobby Tables is wrong. So what Bobby Tables said was, I hope you've learned to sanitize your inputs. You don't do database, you don't do input sanitization to stop SQL injection. You stand up, get up. How do you stop SQL injection? Prepared statements or query, give them another plus. That's the right answer. Bobby Tables, this is a cartoon that's famous that talks about SQL injection, and the answer that he gave in that cartoon is wrong. You don't sanitize inputs. You parameterize queries like this. So here's the secure usage. I'm building a query, update employees, set name is question mark, where the ID is question mark. We bind this potentially dangerous data into those placeholders, and SQL injection goes away. It's really that simple. This is one of the most destructive vulnerabilities in a web application, but it's one of the easiest to fix. And when you do use parameterized queries, the performance of your application goes up dramatically. Now there's a website called Bobby Tables. This will show you how to do parameterized queries in every major language. Is anybody here a programmer? Who's a programmer? Anybody here work with one? You're the only programmer. Hello, sir. Does anybody here work with programmers? Does anybody here do security and is responsible for the work of other programmers? Wow, okay. So here's your job, everybody. Go find a programmer and show them these websites, Bobby Tables and some of these resources. This will teach them about what SQL injection is and how to fix it. It's not that difficult, and it's extremely important to the security of Nepal. Okay, we're talking about defense. We're looking at defense category 4. When you're building a user interface in the web, if I put a character like this on the web browser will think this is code, and it will cause a code to execute that may have come from an attacker. This is called cross-site scripting is the name of that attack category, or JavaScript, or content injection on the web. We want to escape data. We want to take all dangerous characters like this and convert them to a form like this, which will display a less than symbol without treating it like code. This is the most important defense when doing any kind of injection defense. Whenever I take data that a user submitted, their name, some data field they entered, their profile, whatever, any data that a user submits, before we add that data to a parser, like a SQL statement, or before we add it to a browser, before we add it to an LDAP call, we have to escape it so we convert it to the proper format, so it's just display or just data and not actual code that's being executed. There are many ways for an attacker to upload data to your application or to your server so it gets treated like code. Do you want attackers executing code on your server? What's the answer? No, you don't. So I'm going to jump ahead here a bit. The solution, if we look at these projects, those of you who are .NET developers, we have the Microsoft Encoder. It's a scaping library to build a user interface. In the world of Java, we have an OWASP project, the OWASP Java Encoder project. This is a bunch of escaping routines and encoding routines to take dangerous data and make it safe before you add it to your application. What else do we have here? Here's other escaping libraries in every major language. Again, I'm going to give you a copy of these slides. We're going to move fast, but you'll have access to these slides to look into the details later on. So Ruby on Rails, PHP, Java, Scala, .NET, Go, all of these different languages have escaping or encoding libraries built into them in some way, so you can stop these injection attacks. Here's some other resources. There's many kinds of injection. There's command injection, remote code execution. There's LDAP injection. There's all different ways that attackers can run code on your server. Here's some additional things you can read to learn about this. And be careful, cross-site scripting and all these forms of injection, they are extremely destructive and often difficult to build in a secure fashion. Whoa. So you want to use different tools to scan your code and scan your applications to look for these issues. And here's a variety of resources that you can read to learn more about cross-site scripting. Is anybody here doing bug bounties at all? Bug bounties? Cross-site scripting is an easy thing to find in bug bounties. I know plenty of people who make a living scanning for cross-site scripting, reporting cross-site scripting, and making money by using this page right here, the cross-site scripting filter evasion cheat sheet. It's how you can build an attack that will get through filters in a bug bounty to let you find cross-site scripting so you can make some money. There we go. We like that. All right, level 5. The fifth most important control that you need to master is input validation. That's our next topic of discussion, input validation. One of the projects that I like is called the OWASP HTML Sanitizer project. This is a specialized filter, a specialized validation layer. When a user is authoring HTML, we may want to add that HTML to our website. This is a project that will take HTML from a user and make sure it's safe, that we can display to another user. And this is a relatively important control because it's extremely complicated. It's an easy way to attack a website. And so what we do is we build a policy. We say, I'm going to allow HTTP and HTTPS URLs. I'm going to allow image tags. I'm going to allow border and height and width and everything else. Every other HTML tag will get removed from input. This library is important, again, because it allows a user to author HTML, submit it up to your server so you can display it to other users in a safe fashion. A lot of websites will let users put HTML tags in their input. And this is a difficult thing to do in a secure fashion. And if you look at all of these other websites here, all these other projects here, we look at JavaScript, Python, PHP, .NET, Ruby on Rails, they all have some kind of specialized HTML validator built in. It's available to your programmers. We've been focusing on web security for well over a decade now. The knowledge to build secure web applications is there. If we just inform developers of how to do it correctly, they will. They'll at least try to build secure software. And again, the libraries and the tools that we need to get this right is there and available for all of us. We just have to use it. What's your question, Vikas?
So if you cannot control the input sanitization, what compensatory control would you advise?
Tell me that one more time. If you cannot control validation,
Yeah, you cannot do input validation because those certain characters are part of your software. They are allowed. So what compensatory control would you allow?
So let's talk about building a secure user interface on the web. If the data that you're adding to a web page is just a string, there's no markup in it, there's no HTML, it's just display data, then you want to use escaping. If the data that a user is submitting is HTML, then you want to use an HTML sanitizer, like we see here, right? If the user is building JavaScript programs, well, they have to use safe JavaScript functions to display data. If you're taking JavaScript or advertisement for a third party, you want to sandbox it in like a sandbox iframe. If you're dealing with JSON, if you're embedding JSON, you want to serialize JSON. The point I'm trying to make, Vikas, it's complicated. And especially when it comes to SQL injection, just say it, go ahead. Parameterized queries, he knows, it's easy. When it comes to building a secure user interface, the web is wicked complicated, only getting more complicated. We need all of this knowledge to get it right. And I'm talking about one little slice of it, HTML sanitization. So what you can do though, Vikas, is you can do content security policy. This is also extremely complicated, but it's another standard that you can add to your web page that when the browser gets this policy, it will limit what's allowed to execute in the browser. I wish there was an easy answer. There's not. Building a secure web page with lots of different kinds of data is extremely complicated. All right, where are we here? So let's talk about, so we're talking about input validation, and we're talking about complicated forms of input validation. Do you ever see a website that lets you upload files to that website? Hey Jay, how much damage can you do if you're allowed to upload files to a website and that feature is built with poor security?
Command injection is the first thing that comes to mind.
Yeah, once you have command injection, that's no longer my server. That's your server. You win.
There was a new virus local service that popped up a few months ago where you could scan, and all you had to do is just upload a file name, semicolon, whatever.
What I like is, ever see the GIFRs before? The GIF shells? There was an attack where you could build a specialized GIF image. It was named .gif. It had the header of the GIF, but the rest of it was a shell. So I upload the GIF, and you say, no problem, put it up on your server, and I just navigate to that file and add an operating system command as a parameter, and I got a shell on your server using a GIF. That's insane. So when it comes to file upload, it's a very difficult control that's necessary to build secure software. Well, let's just talk about images real quick. When Jay uploads some evil GIF to my server, what I want to do is I want to load that GIF into a program called ImageMagick that will verify if it really is an image. I'll then take the image, change it by 1 pixel, and save it. And if that's not a real image, if it's some kind of shell to do command injection, then it's not the verification process will fail. If it is a real image, the verification process will succeed, and we can then save the file. Again, I'm trying to mention that there are situations where building security controls, like file upload especially, it's very complicated. Make sure your developers have the right expertise to build these features securely. Or turn them off. Right? And one note, even valid data can cause injection. A lot of books will tell your developers to do a lot of input validation, but here I am validating an email address. It's a valid email address, but it's still extremely dangerous. So be careful about building secure software is complicated. It takes a lot of expertise to get right, and you need to have that expertise in your development teams if you want to do secure software. Hey! 9 outside. Okay. Can I see the phone? Can I see your phone? I'll talk to him. I'm in the middle of a talk right now. Can you call back a little bit later? All right, let's look at category. That was for humor purpose only. I'm only kidding. I'm only, namaste, sir. I'm only kidding. I was using you for humor only. I'm sorry, it's for fun. Okay, sorry about that. Let's talk, okay, class 6, or number 6. One more. I just embarrassed him. Everybody give him a namaste. You ready? Ready? 1, 2, 3. Namaste. There you go. All right. All right, let's do C6. C6. Implement digital identity. I want to recommend, and this is a very important part of secure software, it's NIST 863. Look, this is an American standard. This is our National Institute of Standards. I'm not recommending it to Nepal lightly. This is so well built. It's one of the best standards on authentication I have ever seen. I recommend everybody in the world read this. We're going to look at some of the details right now. Can anybody tell me what is authentication? What's authentication? I'll just go for it. It's verifying that some entity is who they claim to be. It's identity. It could be a server, it could be a user. We want to establish their identity as the first layer in any piece of secure software. So my big question is, and by the way, we could talk about identity for weeks. It's a very complex topic. I want to focus on one issue, and that's how do we manage passwords for our users? Can anybody tell me, when you're building a web application and somebody gives you a password when they register for an account, how should we not store that password? Plain text. So that's a good answer. That's how you don't do it. I want to explain how you do it. When someone steals your database and sees the passwords of your users, they can use supercomputing power to crack that password. Here is a hash cracking rig. This rig was defined in an Ars Technica article in 2012, and 4 of these computers networked together could crack any Windows 7 password, in about 6 hours. So this is the problem with modern password storage. Even some of the biggest companies get this wrong. There's also online services to help us do hash cracking for free. And so let's talk about how to get this right. We're going to look at these 6 different ideas of what it really means to do secure password storage. Again, the situation is some user registers to use your website. As part of that registration, they give you a password. And it's your job to take that password and store it in a secure fashion. So even if someone steals your database data, the password is going to be as protected as can be. Step number 1, we want to not limit the password strength. We should allow any character and very long passwords. The NIST standard says the minimum password should be 8, and we should support at least 64 character passwords. I think 8 is too small. I recommend 10. And if you don't have multi-factor, most of my customers are doing 16 as their minimum password size. So I'll leave it at that for now. Number 2, we want to use a modern password policy scheme. A lot of the password policies that we use today are wrong. They're bad. They don't actually help us compete with the modern attacks that attackers use against web services today. So here's my advice. Don't limit the characters or the length of passwords. Have at least 10 characters up to 64. The standard says 8. I recommend more. Block passwords that have dictionary words. Block passwords that have repetition like 6 A's in a row. Block content-specific passwords like a username or the name of your company or service. Check against a list of common passwords in the world today. Troy Hunt and Daniel Miesler, they maintain open source databases of known passwords. We should block between 50 to 150,000 of the most common passwords in use in the world today, because that's how attackers go after your software. We should throttle or manage brute force attacks. We should not force these special character rules. They're nonsense. And we should and stop using security questions. I can look up your Facebook account and find the answer. Also, no more mandatory password expiration. It encourages bad behavior, and we need to support Unicode in our password as well, including emoji. These are not my ideas. This is from NIST 863. So welcome to ThreatCon, because I have homework for you and everybody else. Go read NIST 863B and look at the new password rules. This is one of the biggest changes that we see in password policy in the rule today. Jay.
I've always wondered why don't they support, let's say 45 character passwords, or why don't they support special characters? I've seen banks that don't support them. It's just ridiculous.
And this is why, the leader of this standards, Jim Fenton, this is why Jim put this in there. We need to support special characters. There was a US bank recently, some security professional, she made her password like smiley face, poo, 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 and a ham and a turkey. Seriously, all emoji. And it crashed the whole bank for a day because they weren't ready to support you. But people are going to use emoji in their password. We have got to be ready for it. I agree with you. The other one was, what was the other one you mentioned? Some banks, they only allow 8-character passwords.
Why?
Because they're cheap bastards. And they're not willing to upgrade their mainframe, which has a limit of 8-character passwords. Seriously.
Where's the limit in storage space?
It's like really old mainframe technology has an 8-character hard limit. And there's a lot of banks that still use COBOL because of how reliable it is. And so update your freaking software. Really, because most banks are like, should we upgrade our infrastructure to make sure we support long passwords? Or should we give that money to the executives for bonuses? Ooh, hard to, I'm making a joke. Well, it's kind of true, but I'm making a bad joke. No, it is true. It's just not it's true. Let's move on. Okay, we're talking about how to store sensitive passwords, right? So, how much time do I have, Jay?
I don't know, it's just you can my email.
Okay. The next thing we want to do is use a modern algorithm to store the password. Oh, sorry. First, we do a hash. So if you give me a password, I'm going to hash it. So a very long password is now 512 bits. We're not going to stop there. The next thing we do is we add a salt. This is a random string that's unique for everybody's account. I attach a salt to the password before I protect it, and even if 2 people have the exact same password, it will look different in the database because they each have a different salt. Next, use a modern algorithm. This is the most important slide in this section. You want to use bcrypt, scrypt, or argon2i. These are the only good 3 algorithms in the world today to properly store a password from your user. Anything else you choose is a bad idea. And if you look at PHP, it has bcrypt and argon2i built into the language natively. So it's easy for developers to use these defenses. So here's the basic workflow for password storage. Hash the password, add a salt, a large random string unique for every user, then use bcrypt, and as a final step, go ahead and encrypt the final step as well if you wish to. There's also a good cheat sheet called the OWASP Password Storage Cheat Sheet that several of us have worked on, as well as these other standards, right? We have the ASVS standard, we have the authentication cheat sheet, we have NIST 863-3 that talks about these new rules, and if I could add one more, I would add the OWASP Password Storage Cheat Sheet, where we talk about these rules in great detail. So far, so good? All right. We got 3 more. We're at 7. We're talking about the top 10 defensive controls that we can add to software. Let's talk about access control. This is a very common attack. It's called privilege escalation. It's a way for an attacker with low-level access to conduct many forms of attacks that will give them elevated access in some way. Sometimes these are complex attacks, but often they're relatively easy. Even in Windows to this day, if you give me a normal user account on most versions of Windows, most attackers I know of will be able to gain admin access in a relatively short amount of time using open source tools like Metasploit, even to this day. So access control is a very design-heavy subject. A lot of these mistakes that we make in software, we can fix them after the fact. Well, that's the Earth, is what it means. Hang on for one sec. All right, there we go, a little water. So this is a very design-heavy topic, unfortunately. The point I want to make is, when you're building new software for government, for your telecoms, for healthcare, for banking, for whatever that's important to the country, make sure you spend a lot of time up front designing your access control with a great deal of detail. Once you've made a choice on a certain kind of access control design, it is very difficult to change it after you've released that software. So the most common way of doing access control is with roles, role-based access control. This is a very weak form of access control programming. We want to move to a modern standard like claims, right? In a role, I'll say check if the user is a certain role. In claims, a claims-based access control, I'm asking Encode if the user can access a certain feature. This is what modern access control requires. In the US, we have a standard called ABAC, right? Called attribute-based access control, because role-based access control has failed in the US government in many ways. So I'm jump ahead here. So consider attribute-based access control. Make sure you can support data-specific access control as well. And here's some things you can read to look into this more. We have the access control cheat sheet, and we have special publication 800-162. This is about 4 or 5 years old. It's, again, the attribute-based access control standard. Those of you, again, banking, government, telecom, healthcare, your access control requirements are very complicated, and these are the documents that will help you design access control properly before you build big projects for big organizations. All right, level 8. We're winding, almost done now, folks. The 8th control is protect data everywhere. Who was in class with me yesterday? Who was in class? How often should we use HTTPS, everybody? Always! Is there ever a good excuse to use HTTP in a website? No! This is a big problem in Nepal, right? Go look at Nepal Airlines. We just took a look at it yesterday. The homepage of Nepal Airlines is HTTP. Does anybody know anyone from Nepal Airlines who works there? I want you to call them. What are you going to tell them?
Use HTTPS.
How often should they use HTTPS? Always. That's right. So the first thing we want to do is use HTTPS. What about inside of your company? What if I have a private web service that's in our intranet? Class, should we use HTTPS?
Yes.
Yes. Is there ever a good excuse to use HTTP?
No.
Thank you. I'm just double checking. So when we're encrypting data with HTTPS, there's all these standards that we want to look at. I'm not going to go through them all now. There's a lot of good knowledge out there. So the first one is strict transport security. But I want you to take a look at the website SSL Labs. Again, SSLLabs.com. This is a way you can add your own website to this tool, and it will verify how good your HTTPS is for a certain website. It's not enough to do HTTPS. You have to do it in a well-configured way. So I'm not going to talk about this now. This is pretty old knowledge. HTTPS everywhere, and you do it in a well-configured way, and use the website SSLLabs.com to verify that the work you did is done correctly. Hey, sir in the plaid shirt, you're shaking your head no. Are you saying don't do HTTPS? No? How often should you do HTTPS in your website, sir? Not, no, the plaid guy. Every day, everywhere. You're forgiven. Okay, good. So, let's talk about stored cryptography, stored crypto. So let's say we want to build some crypto and store data in our application with stored cryptography. You're probably going to use AES. You want to avoid ECB mode because it's basically plain text. You probably want to use Galois counter mode, which is one of the most rigorous forms of AES. It's not always available, so you may be stuck with using AES CBC mode, which requires macking. You need a unique initialization vector per message. You have to get your padding correct. You have to get key storage and key management right, and you have to probably isolate this cryptographic process in a separate service. That just gives you confidentiality. You got to HMAC your ciphertext to get integrity. You also should derive integrity and confidentiality keys from the same master key using a technique called labeling. And don't forget to generate a master key, and good luck with that. Nobody gets this stuff right. Building applied crypto is way too complicated. Even amongst the top experts in the world, we get it wrong. So you should be using a well-vetted cryptographic library. I think the best one out there is Google Tink. You know, Google is an interesting company, a little bit of evil, a lot of good. They do some good. There's some Google people here. I love you. Don't get me wrong. You work for an evil company, but you do good, so it's all right. Google Tink is one of the best projects I've ever seen out of Google. Right? Google Tink allows me to connect to very popular key management services like the Amazon Key Management Service and similar natively. It uses all strong, highly secure defaults. There's Java, C++, Go, and Objective-C available that has all interoperable cryptography. This would take me hundreds of thousands of hours to build, and it's open source, well-maintained, and again, integration with key vaults. You should never store a key on a server or in your database. It should be in a formal cryptographic vault is the common answer that we talk about today. Google Tink's one of the best. This other library, libsodium, is from Dan Bernstein and his team. Another excellent library to help you do applied crypto. And this is just incredibly difficult. The most difficult part of doing cryptographic storage is doing key management. And in 2018, we have good solutions, key vaults, secrets vaults. One of the more popular in the commercial world is the Vault Project from a company called HashiCorp. And every major cloud service also has vaults to store keys. And be careful, this is really tough to get right. We have the transport layer protection cheat sheet. There's the documentation from SSL Labs, some of the best out there. And then there's the OWASP cryptographic storage cheat sheet. This is a tough topic, so study hard before you build those kinds of cryptographic services. Almost done here. We want to do lots of logging. You know, one of the theories that I see in the world today is teaching developers to do security engineering is very difficult. It takes years to become a good security engineer. So what I see some companies do is they try to write secure software, but they focus more on telemetry and logging. They log everything, every single little action of every user. They log it with great detail so we can monitor what's happening in an application, so we can detect early when we're under an attack. So log a lot. Now, logging is a bit of a boring topic. Doing logging well is not even that difficult. And if you do logging well, it will give you a measure of intrusion detection that no product can give you. We need developers to log security events inside of code to do this well. So here we have the OWASP logging project, the OWASP security logging project, and the logging cheat sheet that will talk about these topics in detail. It's not very exciting, but it is very important to secure development. Last but not least, we need to handle errors in our application development. So we want to manage these exceptions in a centralized manner. We want to ensure that unexpected behavior in application is handled correctly. This is pretty easy to do. It's just something that a lot of developers, they skip it. And then later on, when bugs happen in code and errors happen during real time, it becomes difficult to manage those if we're not doing error handling correctly. So the conclusion here is we have got to proactively, with intention, early, make the decision that we want to build secure software. We should use a standard like ASVS to define what our security requirements are for our developers. We can also use the OWASP cheat sheet series to help inform developers what secure software construction is all about. There's many other resources at OWASP that developers can use to learn more about building secure software. And next, Jay likes this, we can't just get away with building secure software, we have to test. Who here is a hacker? Who's a hacker? Nobody's a hacker. Okay. So those of you who are hackers, who aren't going to admit to it, who are professional security testers, is what I meant. Security testers. We need to verify security in our software continuously. Not once or twice a year, not like every day. We should be testing for security every day that we're building software. Continuous. In a loop, using automation and tools and pen testers and everything else we can do to verify if that application is being built securely. The earlier we find security bugs in software, the cheaper it's going to be to fix those bugs. What a lot of companies do is they let developers build whatever software they want, and then a week before we have to go live, let's do a little testing. How's that working for you, Vikas? It doesn't work. That's called the hamster wheel of pain. You're running on a hamster wheel, and where are you going? You're going nowhere. You're repeating the same mistakes. So when in a software life cycle should you start thinking about security, Vikas? From the very beginning. And how often should you be testing your software for security? On a regular, continuous basis. And I'm not making this up. This is something the security industry has taught me for a decade now. And it's not easy. It takes great commitment. It takes a whole community of people to work together to care about this. It takes years of hard work. And that hard work will be rewarded with more hard work. That's right. Thank you very much for being here, everybody. Before I finish, does anybody have any questions as we finish this up?
Most of the time we are using for user authentications, Active Directory and LDAP.
Okay.
So what do you recommend? Whether to use the same LDAP and Active Directory for the user authentication, or it's better to use their own developed model for the user authentications?
It's a complex question. I'm going to answer it in a few parts. Number one, LDAP does not scale well for a large number of users. LDAP is usually for an enterprise. Active Directory often has that same limitation as well, where Active Directory is good for an organization, maybe. It rarely scales for millions of users. So it depends on how many users you're trying to support. The trend in the US is stop building authentication. That's the real trend, because if you look at these different standards, the expertise that you need to build your own authentication is dramatic. It's hundreds of requirements. So a lot of what I see my customers in the US doing, they're using services like Ping Identity, Okta, Auth0, these formal identity providers. But they're like mafia though, they're so expensive. And once you start using them, it's hard to roll away from them, and you're paying big money. So if you are going to build it yourself, you want to have testing in place early on. And you don't want any average developer to work on this. You want to have very senior, architect level, security expert developers working on your authentication layer. So this is not an easy, there's no easy answer here. You can build it yourself and you'll be able to achieve better scale than Active Directory or LDAP, but you're going to need great expertise to do it. You can use Active Directory and LDAP, but it'll take you a lot of work to build infrastructure around it and achieve scalability. And you can buy Okta or Ping Identity or Auth0. You can use those services, but you're gonna pay big money, and it requires a lot of expertise to configure them. Those are some of the trade-offs in the world today, and it's important because it's the key for identity. One more choice you can do, which I see which one of my businesses does. We started a small business, a bit discovery, whatever, and for day one, we did not even build a login system. We just used a Google login, Facebook login, and Twitter login as our first rollout. Because then people can use multi-factor. Those providers have relatively decent identity protection. Facebook, not so much, but they've had some mistakes recently. So that's another choice. If you're a startup and you're just beginning to build software, use OpenID Connect. Use one of the other providers. That gets you started, and as your company grows even more, you can make another decision about how to use a more heavyweight login system. There's a complex answer to a complex question.
Thank you very much.
Any other questions? Yes, Vikas.
So if you outsource your software development, how do you ensure that you get a secure software from your provider?
Well, most third-party, they'll say, oh, we know security, you'll be fine, right? No, I'm kidding here. So usually you want to have a contract process. What I like to do is I set security requirements before I even get a third-party group involved. And I say, here's your 200 requirements for software development, and that's in my contract around how they have to build software. And if they're smart, they'll debate those requirements with me before they sign the dotted line. And by the way, I've done this. I've made requirements, like usually 50 requirements for software development, and I'm trying to hire a third-party group. Some of the groups are like, no problem, this is part of our practice already. We'll sign that, no problem. Other third-party groups are like, oh, no, we can't do this. This is too complicated. Well, there's your answer, right? The best I have for you is, this has got to be in your contract process. Once the contract is out and they're writing software for you, it's too late. And there's two kinds of contracts. I want contracts for third-party developers that are part of my development team or that are building software for me as an outsourced group. I want contracts for them around requirements. But if I'm buying software, I want requirements for service level agreements on how fast they need to fix security bugs. Because I want two things. When I'm buying software, I want the right to audit your software to look for security bugs. And I want an agreement from you. When I find security bugs in your code, I want an agreement in the contract around how long it takes you to give me a version with those bugs fixed. And once you bought the software or hired developers without that in your contract, it's too late. That's the best I got for you. Any more questions? It's been a great honor to be here. I love being here in Nepal. Thank you all for being here as well. Namaste.